Hello friends, I welcome you all to the week 6 of the course on automation in manufacturing. Well, in previous week we have seen the microprocessor technology, various components of microprocessor technology, various types of microprocessor technology such as microcomputer, microcontrollers and programmable logic controllers. We have also seen how to program a microprocessor. In addition to that, we also saw signal conditioning devices which are used in automated equipments. Well, let us move ahead and look at the next building block of the automated system, and that is the drives. To provide the motion to the various linkages, to provide the motion to various elements of an automated system, we need energy. And how to apply this energy with precision and with control, that is nothing but the drives. There are various types of drives being used in automation in industry, and the most prominent, the most important drive is the electrical drive. To get the required work done in an automated system, we have to apply the electrical energy. That electrical energy will be converted into the required form of energy. It may be mechanical energy, it may be thermal energy, or it may be chemical energy. So, various electrical drives being used in the industry, in automation industry. In this week, we will be seeing some of the important electrical drives which are being used. So, at the start of the lecture 1, that is on application of electric drives in automation, we will study the requirements of various types of drives in automation. There are basically 3 types of drives used in automation. These are electric drives, hydraulic drives and pneumatic drives. We will see their comparison, their applications in the automation industry. After the discussion on the requirements, we will study the meaning of electric drive, its importance, and then we will look at the classification of the electrical drives which are used in the automation industry. So, let us begin the lecture 1 of week 6. Let us study some of the fundamentals of the drives. We are studying automation in manufacturing. To develop automated systems which are required for the manufacturing operations, we need the equipment. The first important requirement of this equipment is this equipment should be providing the automatic movements, and these automatic movements also should be precise. This equipment should provide automatic and precision movements in the elements of the system, and these elements are the mechanical elements. As we have seen that the equipment, they do have mechanisms, and these mechanisms are having the elements. So we need to have a motion of these elements, and this motion is providing the displacement. The displacement may be required for the conveyance or the transportation, or the relative motion is also providing power or the force. So this power or force is required to transform the raw material into the semi-finished or the finished product. So that we have seen in the metal cutting operation in our previous lecture, that in the milling operation there has to be relative motion between tool and the workpiece, which is providing the material removal operation. If we refer the product life cycle, so in which we have seen basically two different activities, two different sets of activities or operation, which are design related activities and manufacturing related activities. So in the manufacturing, we have seen that basically four operations need to be carried out. These are production, then quality control, packaging, and shipping operation. So for all these operations, we are using variety of equipment. So this equipment required power to operate, and this power will be utilized to have the relative motion between the tool and the workpiece or various elements of that equipment, maybe for the transformation which is required in the production operation, say conversion of the raw material into the finished product. It may require in the quality control operation. The motions are required in quality control operation. Simple example is the CMM, that is coordinate measuring machine. So we should have a very precise relative motion between the various elements of a coordinate measuring machine, which is giving us the measurement in microns. After confirming the quality of the products, then we need to have a packaging operation. In packaging, the major concern is to have an efficient operation. The packaging should be very fast, rapid, and it should be economical. Then the packed goods will be shipped. So for shipping as well, we are requiring various systems. For the shipping, basically, we may require the trucks or automobiles. Inside the factory, we need to convey the goods from one department to the other department, from one shop to the other shop, from one section to the other. That means the conveyance and transportation of raw material, semi finished goods, finished work parts, tools, and machines. So, we need certain systems which are providing the power for the transformation of the raw material into semi finished or the finished product. We need the relative motion between variety of elements. And the third requirement, that the system should be precision. So the power, required motion, and the precision, these are three basic requirements that are to be fulfilled by a system. So for this purpose, we are using variety of drives to carry out these operations. So these operations are basically the production operation, quality control operation, and these drives are required to carry out various activities related to the production, quality control, packaging, and the transportation. So let us see what are the various types of drives which are used in the industry. And the system that provides or that satisfies the three functions or three requirements that we have seen now is called as the drive. The drive is providing us automatic and precise motion, and it is controlling the operation as well of various of elements, which may be the work tables, tool spindles, and many other elements. If we take an example, say a CNC machine tool, which we consider as the best example of mechatronics based system in the automation industry. The CNC machine tool system has various drive motors, and these motors are driving the lead screws. So basically, the motors are driving the system, the motors are moving the system. So that's why it is called as the, the drive systems or the drives. So CNC machine tool, here we are using a drive system which is providing driving of the ball lead screws, and these ball lead screws are giving us the relative motion between the tool and the workpiece. The control unit is actuating the drive motors, and the drive motors are rotating the ball lead screws. The controlled rotation of the ball lead screws is enabling us to have the required position of the machine table. In an automated system, there are three different types of drives are used, and these are electrical drives, hydraulic drives, and pneumatic drives. The electric drives mainly include the DC motors, that is the direct current motor and alternating current motor. The electric drives also comprise stepper motors and servo motors. We will be learning about the principle of operation, constructional details, and the application of the electrical drives in our next lectures. The main advantage of electrical drive is that they are small in size and they are providing us ease in controlling their operations. The hydraulic drives are using the hydraulic fluid. So in general, the petroleum based oil is used at pressure more than the atmospheric pressure. This pressurized hydraulic fluid will be applied inside a cylinder which is having the piston as well. So when we apply the hydraulic fluid inside this cylinder, the piston will get actuated. There is a displacement of the piston, and there would be extension of the piston rod. The piston rod will come out of the system. So that linear motion of the piston rod will be utilized to carry out the intended purpose. That operation may be relative motion or application of the force. That application may be either displacement of certain element or it may be application of force. The hydraulic drives are providing us very large power to size ratio. They are providing very huge power in comparison with the size of the system. We'll be studying the hydraulic drives in the next weeks. Hydraulic drives provide stepless motion with good accuracy. The meaning of stepless motion is that there is a smooth transition from the low level of power to the high level of power. There are no jerks when the power will get transit from the low level to the high level. But the limitation of hydraulic drive is that the system is bulky. Since it involves the fluid, there may be chances of having leakage of the fluid. There may be chances of having corrosion of various elements of the hydraulic drive. So that's why the maintenance of the hydraulic drives is comparatively high and the size also quite bulky. As the elements are facing the problem of corrosion during the construction of these drives, we should have a special treatment to these elements to protect them from the corrosion. The third type of drive is pneumatic drive. In pneumatic drives, we are using pressurized air or gas as the working medium. And by applying the pressurized air or gas, we are carrying out the required operation, maybe the motion or maybe application of certain force. The advantage of pneumatic drive is that the air is abundantly available, and the air is fireproof. These are the two prominent advantages, that abundancy of the air and safety. The pneumatic drive equipment are simple in construction and they are economical and readily available. So as you can see that the compressors are readily available in the market and they are quite cheap as well. But these drives do have certain limitations. These drives are generating low power. Therefore, we cannot use pneumatic drives for the transformation operations, for metal cutting operation. We are using the pneumatic drives for the auxiliary operations, say tool changing, for cleaning or the sensing operation. The pneumatic drives are having comparatively lower positioning accuracy and they are noisy since they involve the compressor like equipment. They produce vibrations and they are noisy. But nowadays we are having very good quality compressors which are producing the less noise. But in comparison with the electric motors, the pneumatic drive creating certain noise. Let us move ahead and look at where exactly we need the drives in a typical automatic system. So as I mentioned previously, the CNC machine tool is the best example to study the utilization of drives in an automatic system. To understand the utilization of drive, let us take CNC turning center. The turning center is producing axisymmetric components. To produce the axisymmetric components, we should provide the angular motion to the workpiece in relation to the tool motion. So on your screen you can see a typical arrangement that is utilized in the turning center. Here we are using a spindle motor. That spindle motor is providing power to the spindle of the machine tool. The spindle of the machine tool is holding the workpiece, and the power from spindle motor to the spindle is provided through the speed control unit. So in traditional turning centers, belt drives are utilized, but in modern CNC machine tools, we are using the variable speed servo motors. So the spindle motor is providing power to the spindle, and that spindle is rotating, it is providing the angular velocity to the workpiece. So when we are having the relative motion of the cutting tool with respect to the workpiece, we are reducing the diameter of the workpiece during this operation. Well, to produce this angular motion of the workpiece, we required the power, and that power is provided by the electric motor. The next application of a drive is for the feeding the workpiece to the tool. The workpiece is rotating and it is providing the primary motion during the cutting operation. It is providing the cutting velocity, but unless and until we will move the tool with respect to the workpiece, we may not get the required size reduction in the workpiece. So for that purpose, we have to feed the workpiece to the tool. To feed the workpiece to the tool, we have to have the relative motion of the cutting tool with respect to the workpiece. And so for that purpose, we should have a table. On the table, we have to attach the tool, we have to mount the tool, and this tool movement will be carried out with respect to the workpiece movement. So this linear motion is possible by utilizing another motor. That motor is connected to a ball screw. Ball screw is a mechanical element. The ball screw is having a ball screw nut. So on this nut, the table is mounted. The other end of the ball screw is supported. So when the feed motor is rotating the ball screw, there is translatory motion of the ball screw nut. As the table is attached to the ball screw nut, we are getting the required linear motion. So in this way, we can have the feeding of the workpiece to the tool, and then we are getting the required work done. Now let us define the electrical drive in the context of the automated system. So we can say the electrical drives is providing the energy for the controlled movement of the mechanical system. What are the various elements of a typical electric drive that we will see? The basic element is the electric motor. As we have seen in our previous slide, we need to have the rotary motion of the ball screw to get the required translatory motion of the table which is mounted on the ball screw. So we'll simply continue the same example. This is the ball screw. On the ball screw, we are attaching the table. To get the translation of the table, we should have the angular motion of the spindle which is driven by the electrical motor. Well, a typical electric drive system is having the electric motor. This electric motor is being loaded by a system. This entire system is called as the load which we are applying on the electric motor. So motor, and there is a load on the motor. Now how the motor will operate? To operate this motor, we need the energy. We need the energy source, and that energy source is the electric energy. But directly we are not giving the electric energy to the motor, we are controlling its speed. So we should have power modulator, because we may need to have various levels of power for variety of the operations. So we do not require the same amount of power for all the operation. To modulate this power, we should have a controller. The controller, a system, generally we do call that controller in CNC machine tools as the machine control unit. In manual operated systems, the human being are controlling, but we are talking about the automation system. Microprocessor technology is controlling the power modulator. So how the microprocessor is taking the decision, the microprocessors are utilizing the feedback which they are getting from the system through the sensors and signal conditioning devices. So we have to monitor the process by using sensors. The sensors are monitoring the angular velocity, in this case, angular velocity, position of the table or the torque. There are certain sensors, those who are also giving the input regarding the condition of the electric motor. We are using capacitance based sensors to find out the runout or eccentricity in rotation of the spindle of the electric motor. So eccentricity in rotation will create the vibration. So either you can use the capacitive based sensors or the acoustics based sensor to monitor the health of the electric motor. From the power modulator, we are getting the input in terms of current and voltages that being used. So meaning is that when a certain amount of current or certain amount of potential difference is applied on the electric motor, it is desired to produce the required amount of angular velocity, the required position of the table, required generation of the torque. So therefore, the monitoring of the current and voltages for which the operations are being carried out, the positioning sensing, measurement of torque and measurement of angular velocity will be utilized by the microprocessor to take the required decision to vary the application of power to the electric motor. So these sensors are providing the input to the microprocessors through the signal conditioning devices. So we have seen in our previous lectures that sensors are providing the passive signals, and we need to convert the passive signals into the active signals which can be understood by the microprocessor technology. So if you look at this diagram, you will find out that electrical drive or electric drive is not only the electric motor, but also it has various other elements, and these are the load or the application itself, then sensors, signal conditioning circuitry, use of microprocessing technology, the power modulator, and the electrical energy source as well. So when we combine these elements together, we are getting the electric drive which is used in the automated system. Now let us see what are the various requirements of an ideal feed drive. The feed drive should provide constant torque to overcome the friction and the working forces. The precision machine tools or precision equipment, they are using ball screw based arrangement. The feed drive should able to overcome this friction, and it should provide sufficient forces to carry out the machining operation. Therefore, the feed drive should provide sufficient constant torque to overcome the friction and the required working forces, the working forces in machining operation, cutting forces. The second requirement of an ideal feed drive is it should provide large variation in its speed. So it is expected to have a wide range of speed variation say from 1 to 20,000, so zero point 0.1 RPM to few thousand RPM. The feed motor must run smoothly. There should not be any jerks. Jerks or the vibration during the operation will definitely affect the quality of the transformation. The drive should provide very small positioning resolution. In general, the present day drives are providing around 1 to 2 micron of the resolution. The feed drive should provide high torque in comparison to its weight. The feed drive should have low rotor inertia. In the feed drive, there are many rotating components, and the inertia of the rotary component must be as less as possible so that its efficiency would be high. We are using multiple axes. We are using the relative motion of various elements of a equipment along the multiple axes. So to have the simultaneous movement of the elements along multiple axes, say X, Y, and Z, we are using multiple drives, and these drives are operating simultaneously. So when we are operating these drives simultaneously, the drives or the feed drives should provide quicker responses. If the response of the drives are not quick, response means we are applying the energy, we are applying the signals to the drive, and the drive should respond to that. It should take the action as early as possible. So let us consider an example that we need to manufacture a contour. To get this contour, we have to have simultaneous motion of the tool along X and Y axis. To have the feed of the workpiece along X axis, we are using one feed drive, and to have the feed along Y axis, we are using another feed drive. There will be simultaneous feeding of the workpiece along X and Y direction. So in this scenario, the feed drive should be quick in providing the response to the signals sent by the microprocessor to it. If the drive is sluggish, if the drive is slow in responding, we may not get the required or the accurate quality. We may not get the required contours that to be manufactured. What are the various advantages of the electrical drives? The electrical drives are providing extensive range of the speed, power, and torque. There is no requirement of refueling. So in the petroleum based energy drives, we have to fuel the equipment. So that requirement is not there in electrical drives. The electrical drives are green. They are environment friendly. They are not producing any toxic gases, or they are not contaminating the environment. The electrical drives are providing stable speeds, which is often required in many precision operations. There are certain limitations to the electrical drive. The fundamental limitation is that access to power, the availability of power. In remote areas where there is a scarcity of electrical energy, the electrical drive based automated system or electric drive based systems are unable to operate. So that is one of the limitation, that we need to have the continuous access to the electrical energy, electrical power. The initial cost of some of the electrical drives is quite high. Basic electric motors are quite economical, but the servo based motors, or the motors which are used for the automation purpose, which are having the inbuilt feedback system as well, they are quite costly. Therefore, we need to invest a little high when we are trying to utilize the services of the electrical drives in the development of our automated systems. Some of the electrical drives may provide, some of the electrical drives may create the noise. So when the electrical drives are not in proper condition, they are generating the pollution. We have seen the basic applications of electrical drives in the automation, such as providing the motion and power to variety of mechanical elements, and various applications required in packaging, in quality control, and in the shipping. As far as in general applications are concerned, the fundamental application of the electrical motors are in transportation. So we are getting the electric trains, buses, trolleys, trams, and many solar powered vehicles. Of course, the solar energy will be converted into the electrical energy, and that electrical energy will be utilized to get the movement of the automobile. The electrical drives have enormous applications both at domestic as well as the industrial level. We required the motors, particularly in all factories, textile mills, to operate the pumps. We required the electric drives in robots, which is very interesting application nowadays. The electric motors are classified into two groups. These are DC motors and AC motors. The DC motors are direct current motors, while the AC motors are alternating current motors. In addition to these DC and AC motors, we can have the other types such as stepper motors. When we use sensors to monitor the revolutions of the motors, that motors are called as the servo motors. The direct current motors are further classified into two groups. These are brushed motors and brushless motors. In brushed motors, there is a commutator and brush assembly, which is energizing, which is passing the electric current in the armature. So it has the arcing problem due to the friction between the brushes and the slip ring. In brushless motor, this limitation has been removed. The alternating current motors are further classified into two groups, that is synchronous motor and the induction motor. In synchronous motor, a three-phase rotating magnetic field is used to get the required rotation of the rotor. In the induction motors, the electrical property, that is the inductance, is used to energize the rotation of the rotor. In the next two lectures, we will be seeing at a preliminary level the constructional details and principle of operation of some of the important motors. These are DC motors, AC motors, stepper motors, and servo motors. Well, my friends, let us summarize the lecture 1. In this lecture, we discussed about the requirements of motion and energy for various operations in an automated system. So, for that purpose, we learned that we need power. That power we can get from electrical energy sources, and that electrical energy further may be converted into the mechanical energy. That mechanical energy will be utilized to carry out various automation operations. So, the automation operations may be required for the production, that is for the fabrication, or it may be required for conveying the products, or it may be required for packaging. So, there are various operations are there in the product life cycle. For these all operations, we have seen the requirement of the drives. So, to carry out variety of product life cycle operations, there is a requirement of various drives. That drives we have seen, the drives are electrical drives, hydraulic drives, pneumatic drives. After that, we learnt the importance of electric drives, its advantages, its importance in the present day automated industry. At the end of the lecture, we discussed about the classification of electric drives in detail. Now, in the next lecture, that is lecture 2 of week 6, we will study the basic types of electric drives. The fundamental electric drive is direct current motor. AC motors are also used in the industry. We will study the working principle, construction and applications of these types of motors in detail. Thank you.